So you're a big fan of Rubik's Cubes. One day you're solving your cube, and as you do so, you try to perform an awkward twist and suddenly a piece falls out. As you're trying to put the piece back into its place, another piece falls out. You do your best to put them both back in the right places, but you can't help but feel that you may have mixed them up. And once you get the cube back in one piece, you realize that you're actually not able to solve it anymore. Now you're pretty sure at this point that the cube can't be solved, but then again, you're always prone to human error as you are a human, so you go ahead and enter the cube configuration into an online simulator that will tell you how to solve the cube if it is in fact possible. And when you do this, unfortunately you find out that it is not possible for you to solve a cube that's configured that way, which means that the cube is essentially broken. It should be noted that the inability of the online solver to offer a solution could be a flaw of the programming rather than the actual cube. We are operating here under the assumption that the solver's claims are correct. Believe it or not, standard 3x3x3 Rubik's Cubes are actually built in a way that they can be taken apart without actually damaging the cube. A standard Rubik's Cube contains 26 pieces, namely 6 center pieces, 12 edge pieces, and 8 corner pieces. Each center piece has 1 sticker, each edge piece has 2 stickers, and each corner piece has 3 stickers. If we take apart the cube, we can see that the skeleton consists of only the 6 center pieces, which cannot move from their places, and that when the cube is put together, the other 20 pieces will simply revolve around the centers when the centers rotate. It's worth noting that the Rubik's Cube is rotationally symmetric, which means that if we do a process starting from the red face, for instance, it would have the same results as doing the process starting from a different face, assuming everything else in the process remained the same relative to the original change.
I'm going to talk about rotating corner pieces of a Rubik's Cube. I'm wondering if the Rubik's Cube is still solvable if we somehow rotate its corner pieces. Rotating corner pieces mean we pick a corner piece and rotate it either like this, which I call counterclockwise rule because all the color of the piece move counterclockwise from their original position, or like this, which I call clockwise rule because all the color rotate clockwise from their original position. So let's try some example to see if the cube is still solvable or not. Here I have a corner piece which has been rotated counterclockwise. Let's try to solve this Rubik's Cube. Nope, it's not solvable. Here I have another corner piece which has been rotated clockwise. Let's see what happened. It's still not solvable. Here we have a situation that two corner pieces have been rotated counterclockwise and clockwise at the same time. Now let's try to solve it. It's solvable up to 14 steps. Here I'm using a spreadsheet to illustrate my examples. The 4 columns represent number of rotation of 4 corner pieces of a Rubik's Cube. I gave a counterclockwise rotation a value of -1 and a clockwise rotation a value of 1. And here the sum of all value of 4 corner pieces, and the last column represents the solvability of the Rubik's Cube. For example, in line 2, if there are only 1 corner piece rotated counterclockwise, then the cube becomes unsolvable. Another example in line 5, if there are 2 corner pieces rotated counterclockwise and the other 2 rotated clockwise, then the cube becomes solvable. After doing a lot of examples like this, I realized that the cube will stay solvable if the sum of all corner pieces value is divisible by 3, for example, 0, -3, -6.
Rotation rule. Assume counterclockwise rotations have a value of -1 and clockwise rotations have a value of 1. The cube is not solvable if the sum of the corner pieces' rotations values is not divisible by 3. We suspect that this has to do with the fact that the corner pieces have 3 stickers. There are 3 ways each corner piece can be oriented, therefore making 3 turns in one direction is effectually the same as making 0 turns. The trend is that as long as the sum rotations cancel themselves or each other out, the cube can be solvable. We did not explore the rotation rule as applied to edge pieces, but we hypothesized that edge pieces would work similarly, except that the sum of the rotation values must be divisible by 2 instead of 3 because edge pieces have 2 stickers.
Keep in mind that when swapping pieces that the cube's rotation value follows Long's rotation rule. So we've looked at rotations, but what happens if we look at swapping pieces? Since you can't swap a piece without swapping it with another piece, you have to swap pieces in pairs. Swapping a piece is when you transpose one piece with another piece on the cube. The trend appears to be that when you swap an odd number of pairs, the cube is unsolvable, but when you swap an even number of pairs, the cube is solvable. Our next thought was, how does this trend relate to corners? We found that corners follow the same trend. We've only been showing the number of swaps of multiple edge pieces being swapped or corners being swapped, but we've tested combinations of both and found that the cube is still solvable as long as the total pairs being swapped is even. Please note that due to time constraints, we are only showing one possible way to swap the pieces. We've tested other possible ways to swap pieces, and they do work, leading us to conjecture that the position of pieces being manipulated with each other does not matter as long as they are the same type of piece. Something to point out is that on the simulator, it looks like we are just switching stickers, but think of it as swapping pieces. This would potentially still allow the cube to be solved as the piece existed in the first place.
Piece swapping rule of pairs. If an odd number of pairs had been swapped, the cube is unsolvable. If an even number of pairs had been swapped, and the rotation rule does not prevent the cube from being solvable, the cube is solvable. We in the Rubik's Cube group would like to thank RubiksCubeSolver.com, which was used to check our work and provide visualizations of the cube being solved. Due to time constraints, we were not able to show every possible swap or rotation that could be made with the cube, for instance, swapping 3 or more pieces instead of pairs, combinations of swaps, etc. This could be a point of further inquiry.